All right, well, we'll go ahead and get started here. First of all, thank you for your continued interest in Wood-Mizer blades and for taking the time to celebrate our 25th anniversary with us. My name's Randy Panko, and I'm in the Wood-Mizer Blades division, and I'm looking forward to this opportunity to meet with you folks today. Today we're going to talk about processes, profiles, and applications. And by the way, did you know that Wood-Mizer is the only sawmill manufacturer to also make our own bandsaw blades? When we originally developed the mill back in the early 80s, we actually bought material from other manufacturers, cut it to length, and welded it. Then, as we further developed our sawmill line, and as we started sawing different species under different conditions, we found the need to actually make a higher quality and a better blade with different profiles, widths, and thicknesses. And that's how we actually got into manufacturing our own blades. We'll talk about it quite frequently today. Quality is real important to us. We have over 100 separate tests and inspections for our blades in our manufacturing processes. We use computer-controlled equipment in almost every step of the way, and this ensures correct measurements and strict controls of our bands. We also utilize a unique blade ID tracking number. This enables tracking of our manufacturing processes and even the person or the individual that welds our blades. Wood-Mizer manufactures two different types of blades. And in the late 80s, we started out with the double hard blade. It's made of a high quality alloy steel, especially developed for narrow bands. The teeth are induction hardened, which helps them stay sharper longer, gives them a higher wear characteristic, and we can resharpen those blades often or multiple times. Double hard blades mean higher productivity and lower cost per board cutting foot. The silver tip blade, we brought that online just in the last 5 or 6 years. We originally brought it out for high volume resawing applications, and it's a lower cost blade where you can actually throw the blade away or maybe just resharpen it a few times. The silver tip uses the same tight manufacturing specs as the double hard, and it's more consistent than the competition. And once again, this is our high carbon steel blade. Generally speaking, you may not get as many resharpenings out of this material, but still a good blade for a lot of different sawing applications. Wood-Mizer blades, we're committed to the finest manufacturing processes. Now let's take a few moments and talk about some of these manufacturing components that make our blades a winner. We begin with the steel. Here you see a video clip of our narrow band stock coming in. When that steel comes in, we actually take it right off the bat and we cut a weld sample for heat approval. And here you'll see a picture of the equipment that we use to test that weld sample. We then polish the welds. We check for steel structure. And here you'll see a picture of the device that actually tests the hardness of that weld. This is our micro hardness test, and this is where we check the weld for structural integrity. Then we enter the data and we review it. And step 5, the blade steel is approved for production. Punching. Here you'll see a video of our blade stock being uncoiled, and we punch it. As that material exits, we simply recoil it back up, and we prepare it for the next process. Heat treating. There you'll see a picture of the blade before the tooth is embedded, induction hardened. And there's a shot of it coming out. You can see at the top of the blade has been treated and hardened. Precision grinding. This is a video clip of our blade going through a grinder. And this is done by a CBN grinder. And this ensures the tooth profile to be consistent. We actually are doing a plunge grind where the CBN grinding wheel is pre-shaped and formed to meet the profile of your blade. So rather than changing hook angles and using a sweep process in our grind, we have a grinding wheel pre-shaped to fit our different profiles. Computerized setting. Here's a shot of our blade going in. You'll see the teeth are straight up and down with no set. And here you can see we actually use a raker style configuration where we have one tooth set out, one tooth set in, and our raker tooth is straight. Our computer controlled setter ensures a consistent set for excellent cut quality. Identification. We've talked about this before. And here you see a shot of our stamping process where we can actually put the name of the company in there and the significant numbers and letters that tell us a lot about that blade. Welding. Here you see a video of a blade being welded. We use Ideal welders. And this video will show you bringing the butt of the blade together, actually welding. Then we anneal that weld. We raise that heat up to make it flexible and pliable. And then we actually grind the slag off the top and the bottom of the blade in the small amount that's caught into the gullet of the blade. Once that blade has been annealed and we've ground the weld, then it simply goes into our packaging process. And we use both the flat pack and cubed boxes. And generally speaking, as we go wider and a little bit thicker in our blades, then we go to the flat pack, easier to open. And when our blades are cubed, they'll come in boxes of 10. Quality control. Here you'll see a comparator that we use. We actually pull blades off our manufacturing line. We put them in this comparator. We check hook angles, back angles. We can look at set. And just another important part of our quality control process. Our manufacturing processes have been developed by our Wood-Mizer Blade Research and Development team. Most of this production equipment has been designed and built by them, and we use very few off-the-shelf components in our manufacturing process. Our commitment is to quality. Test, 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 and strict controls. Don't let them out the door till they're right. Okay, let's take a few moments to talk about the right blade. How do we choose the right blade? Well, first of all, let's look at how to interpret our blade numbering system. The first part of our system is a B, and this is how we sell our blades. We either distribute them in boxes of 10 or 15, but we also have single blades, and you'll see the U stands for single blades at a time. Maybe you wanted to try a different width, thickness, or profile. You didn't want to purchase a whole box. Well, feel free to buy blades in singles to actually give them a test. The first digit in our system stands for the thickness of the blade. One's for 035 and two's for 042. When we first started manufacturing blades back in the early 80s, low horsepower, not looking for a whole lot of performance at that time, the 035 and the 042 blades worked very well. But as we developed more horsepower, more features on our equipment, well, this gave us a need for more performance. And that's when we started developing the 045 blade, the 055 blade, the 50, and the 038 that you'll see at the bottom. Tooth spacing. Tooth spacing is the distance from the tip of one tooth to the next. Generally speaking, Wood-Mizer blades utilize 7/8 tooth spacing. We also do have a 5/8 tooth spacing blade, and that's noted by the number 5. That's generally used in resawing narrow material for pallets or fencing. And one of our newest additions to the product line is 1 1/8 tooth spacing. And that's signified by the letter 9, and you'll find that in our 055 blades in the 1 1/2 and 1 3/4 thickness, and also our 2-inch 55. Okay, the third digit that you see in our part numbering system, well, that stands for the width of the blade. And as you can see, we manufacture blades in 1-inch widths, 1 1/4, 1 1/2, 1 3/4, and 2-inch wide blades. The 4 stands for 1, 5's for 1 1/4, 6 for 1 1/2, 7 for 1 3/4, and 8's for our 2-inch band. The 7/4 that you see right in the center of our part number system, that signifies silver tip only. We do have a few aberrations to that you might see at some time, but for the most part, if you're buying silver tip, you're looking for that part number, you'll see that 7/4 right in the center. 158 inches, that's the length in inches of our standard Wood-Mizer blade. If you would happen to have an LT70, that requires a 184-inch length blade. There are other equipment out there that requires different length blades. Basically, Wood-Mizer will cut our blades to any length. The last number part of our identification system, that gives us a special condition that our blade can be used for, the hook angle, the profile of that blade. We talked a little bit about the 4-degree. That's developed for extremely knotty frozen wood, hardwoods. We also have the 9-degree blade for harder frozen wood, and we'll talk about those differences here in a little bit. 10 is our standard series. That's what we started out with years ago. And 13 degrees for softwood. The last part of our system, you'll see here an S. That means that blade's a standard length. Not only can you get the 158 and the 184 in a standard length, we've also taken some other popular lengths and made them standard. You'll see the C, that signifies that it's a custom length. And if you decide to order custom length blades with us, please be sure to give us the correct length of your machine. What are some of the factors to consider in selecting a blade? The hook angle. That's the angle of our tooth leaning forward. Generally speaking, the very tip of that tooth is what does the sawing. That tooth actually hooks itself into the wood, shaves away the wood. Those sawdust particles and those chips of wood, they roll around in the gullet and they get thrown out of the cut. The hook angle of blades, good blades for softwoods will have either a 10-degree or a 13-degree hook angle. For hard, frozen, or knotty woods, the 4 and the 9 are most popular, but you can also use the 10-degree profile there. And the 10-degree is a good all-purpose profile. So if you're a woodlot owner and you just want to have a couple of boxes of blades laying around and you don't want to have a bunch of different profiles, the 10-degree blade is just a good all-purpose blade that you can use in general sawing conditions. Blade thickness, that's actually the thickness of the blade that we talked about earlier. What do you get out of thick blades? Well, thicker blades can give you performance, which means a higher cut quality, straighter lumber for a longer period of sawing. It can give you faster feed rates. accurate sawing, as I just mentioned. But thick blades require more horsepower. Thin blades, on the other hand, can give you longer flex life. Because they're thinner, they can spin more around that C-frame before they fatigue. They need less horsepower. And thin blades are good for lower production, slower sawing, or if kerf is critical. If the kerf of the blade, which is the thickness of the blade plus the set that you have on each side, if you need to get a certain amount of material at a certain height cant, then the kerf of the blade will be important to you. Let's talk a little bit about blade width. And that's just the width of the blade, from the back of the blade to the tip of the tooth. Wider blades can give you faster feed rates, more resharpenings if your equipment is maintained and you sharpen your blade correctly, and it can give you higher performance in higher horsepower. And generally speaking, wider blades are good for the LT70s, the higher horsepower Super, the LT300, and some of our other higher performance sawmills that are out there. And they're best in the 050 and the 055. Narrow blades, well, they're good for lower horsepower sawmills. Sometimes narrow bands are ideal for difficult sawing. And if you think about, we talked about how the tooth shaves away the wood, rolls around those particles and that chip in the gullet and throws it out of the cut. Well, if we're not throwing that material out of the cut and it spills over the side of the blade, it can generate heat. It might have a tendency to steer the blade. So keep that in mind, and when you get into tough sawing, sometimes the narrow blade, especially in frozen wood, will give you the opportunity to cut that wood where a wider blade may not. Let's look at some of the considerations you need to make when you're selecting your blade. Width, thickness, and horsepower. What gives us long blade life? What ensures accurate lumber? Well, first of all, you can prevent premature breakage and blade failure simply by using Wood-Mizer blades in the silver tip and the double hard. With all the equipment that we have to make the blade, our quality control, our customer service, we can give you a blade that will offer you good sawing, good performance, and accurate lumber even in the toughest of conditions. How can we overcome common blade problems? First of all, we recommend that you use Wood-Mizer's Resharp service. We have facilities in Madisonville, Kentucky, Noonan, Georgia, Hannibal, New York, Missouri, and Portland, Oregon. How do you use our Wood-Mizer Resharp program, and what do we do with your blades when we get them? First of all, we make it very convenient. We provide an ARS label for you that you very simply just slap on your box of blades. You take them anywhere UPS picks up or delivers, and they'll bring those blades back to us. Then what we do is the $10 charge for that ARS label, we add that onto your bill at the end. Once we receive your blades, the first thing we do is we give that blade a pretty good heavy grind. Then, believe it or not, and I don't think you'll find anybody else that does this, we actually put your blade through a process where we wash your blade and we bring that set in. We actually equalize that set. Then what we do is we go ahead and set the blade. Now that the blade's cleaned, we've brought the set in, now we can give it the set that's required to make that blade symmetrical. Once that blade's set, then we give it one final grind, which is a lighter grind than the first process, to put that face angle where we need it to be, and to give it that edge that will give you the performance that you're looking for. The blades simply then either go back onto our packaging table for the flat pack or the cubed box, and it's on its way to you. Another thing you can do to overcome blade problems and premature blade failure is to evaluate the things that we've listed here. Wood cleanliness, if it's the middle of spring and you've got to cut through 6 inches of mud, that's going to affect your blade life. Blade tension, okay, we want the appropriate amount of tension, whether your machine's an LT15, an LT40 HD, a Super, a 70, a 300, or you have another manufactured sawmill, blade tension is critical. Feed rates. Well, you might say, why do I need to evaluate my feed rate? When you're sawing, when you're using your mill, you want to lean on your feed rate. You want to saw as fast as you can to maintain a straight cut and utilize that horsepower. If you're cutting slow, you're simply wasting blade life. That blade's going to spin 4,400 surface feet per minute, 56 or whatever it might be. And if you're just cutting real slow, you're just wasting the life of that blade. So it's important to keep consistent feed rates. Blade guide position. And we'll get into this in a little bit further into the presentation. That blade guide that's on that sliding arm, keep that as close as you can to what you're sawing without actually touching it. This is going to help you maintain accuracy and maximize the life of that blade. Use large logs. Large logs will give you more production or more lumber per saw line. You'll also have less handling if you're sawing large logs. So this will just give you more lumber out of your blade than if you're sawing smaller logs. Let's talk about feed speeds. It's important that you understand the inconsistencies in sawing softwoods. What do you find in softwoods? Knotty softwoods, your pine, your fir, your hemlock. How about the knots? Well, the knots are extremely hard. How about between the knots? It can be soft. So you may need to set your blade up for the knots and then maybe slow down just a little bit between the knots. Hardwood, generally speaking, is more consistent. And once again, when we talk about feed speeds, we want you to saw as fast as you can with straight lumber to maximize your blade life. Moisture content. The density can change with dryness. You know, certain times of the year, towards the end of summer, when your logs have sat out all spring and summer, now they're getting dry. Even though they're a softwood, they could be difficult to cut. Extremely dry softwoods cut like a hardwood. And dry woods are more abrasive on blades and can require lubrication. Lubricating the blade can be critical in sawing some species under certain conditions. I think it's very important that if you don't use anything, put water on the blade. Wood-Mizer offers a lubrication that you can put in your water tank that you can use with your mill. And the data just jumps right out at you with lubrication. It can enable you to cut species, exotic hardwoods, dry woods, that otherwise you wouldn't be able to saw. And there are other lubricants that are also valuable. You can use pine sol, vegetable oil. Used with liquid soap is a good combination for a lubricant. And just keep in mind that if we don't keep that blade clean and lubricated, it can heat up and it can lead to breakage. Clean wood, we covered this a little bit, but dirt, rocks, sand in the logs wear a blade faster. If you have the opportunity, I would highly recommend you put a debarker on your mill. Just the fact that it cleans that path for the blade, eliminates contact with the bark, it's going to pay for itself in a very short period of time. And if you don't have a debarker and you're stuck cutting dirty logs or muddy logs with debris in them, you might consider taking the flat side of your log and turning it out so that your blade's actually entering the clean side of the log and exiting through the bark. You'll find that that can help you out considerably. Blade tension. Proper blade tension is critical for maximum performance and cutting speeds. So if you start out in the morning and your blade tension was where it needed to be, now the sun's come out, the atmospheric conditions have changed, and you find that tensioner creeping up closer to 3,000 or higher than it needs to be, take the time to back that off, back down to the appropriate tension. High blade tension gives you good performance. It will help you cut a little faster, but it also affects the life of your blade. And if you're sawing along and maybe you get into a hard spot of a log, or maybe your blade does a little dive and comes back up and your blade tension's backed off, maybe you haven't been using water and your blade tension's backing off, it's really important that you take the time to go around and bump that pressure up where it needs to be. Okay, let's take a few moments to talk about the blade wheel belts that go around your blade wheels. A worn belt can allow the blade teeth to come in contact, actually come in contact with the rims of that blade wheel. So it's important that you change those belts. What a lot of people do, since the drive side belt wears quicker than the idle side, simply pop the belts off, swap them, and you can actually get a few more hours sawing out of those belts. You might consider lubricating the belts to keep them from dry rotting. A little WD-40 or some type of lubricant can once again help you to prolong the life of that belt, which is going to help your blades cut longer and help you get the most out of your blades. It's also important, I'll take just one more moment, to help you understand that those belts are a Goodyear belt or a belt that's manufactured by Goodyear. If you go down the road and you purchase an inexpensive belt manufactured by someone else, you could run into problems right away. So keep that in mind. Okay, once again, high feed rates. Fast cuts promote overall blade life. Keep your feed rates up. This is really important. Your blade guides are a critical part of what makes your machine perform. Proper alignment allows for higher cutting speed. Proper alignment gives you maximum blade life. If you can go up and grab your blade guide rollers and you wiggle them, or they've got slop in them, or they've got a flat spot on the blade guide, or maybe that flange that holds that blade guide from coming off is wearing real thin, then you need to take care of that. You need to replace the guides. You can rebuild the guides with the bearings. Also, keep an eye on that blade guide arm that slides in and out. If you can grab that blade guide arm and wiggle it, or it has a lot of slop in it, that can also lead to premature blade breakage. Why? Because when you're leaning on that mill, when you're trying to cut hard, and that blade moves back and forth with your blade guides, your sliding arm, well, that's just simply going to generate heat on that blade. It's going to lead to cracks in the blade, even though you might not be able to see them, and premature blade breakage. So keep your guides adjusted, keep them parallel to the bed. It's important that your blade guides are sitting level not cocked up, not cocked down. We do have the blade guide tool. It's a simple device that clips on that blade that will help you ensure that your blade's sitting parallel with the machine and you're cutting. Okay, we'll wind it down talking about a little bit about woods, timber, softwoods, hardwoods. I put up here a brief list of softwoods. Generally speaking, they're easier to saw material. Balsam, aspen, cottonwood, sycamore, for the most part, pine. Some people put poplar in this mix, but just softer woods, easier to cut. We have medium to hardwoods. What I've listed here is red oak, yellow poplar, walnut, cherry. Once again, some pines, depending on the condition they're in, the size of their knots, they can be easier to saw, harder to saw. And here we have a list of hardwoods. White oak, hard maple, ash, hickory, Osage orange, and barn beams. If you're trying to cut difficult species or hardwoods like this, first of all, use a thicker blade. That additional thickness is going to allow you to cut through these species, give you maximum performance. And I would also suggest that you use a lubricant. Oftentimes, a lubricant and a thicker blade will allow you to cut hickory that maybe you couldn't do before, will allow you to cut barn beams, hard maple. Exotic hardwoods can be difficult to saw, kiln dried. You can treat them as hardwoods. And we're kind of winding it down now. I appreciate your attention. We're always available for questions or any concerns you might have. And at this time, I'd just like to open it up for a couple of questions. All right, well, thank you for your time. Thank you for coming to this event and celebrating 25 years with us. And we look forward to seeing you in 25 more. Good minds and blades, best blades in the industry.